Hi, welcome to our latest installment where we're going to be talking about RAD wireless today. For some of you that may have seen my LinkedIn post, one of the things that we talked about, or I talked about, I should say, is what we discovered after our time with James, and that is that wireless is hot. And I'm joined here with Pete and with Mac. I think they would agree that we're in a interesting time, not just from a business standpoint with what's going on in the environment around us, but just the business in general. Before all of the COVID discussion even started and the challenges here, just hey, there's a lot of opportunity when it comes to wireless and comms, and I think you both would agree that this is something we've had a passion for many years. And Pete, obviously this is kind of your big area that you've spent years building. And
Wait, I don't have an Intercom headset to show you. I don't understand.
I know, but we're going to believe it because you're wearing the Intercom of the future. Like it or not, it's going to be Bluetooth earpieces. It's going to be bringing your devices to work days. But before we go to that, let's just kind of get ready for today's topic. Pete, kind of walk us through how we're going to interact with our presenters today and get our questions in.
On your display, there is a section called questions. You can type them in there and we will see them. If they're an actual question for the presentation, we'll pass that question on. So unfortunately, Jeff Jones, we're not going to pass on the say, hi, Jeff Jones here in Ann Arbor. Other than that I just did. So we're going to sort of, I'm going to toss it to Mac for a second, and we'll be watching, and I may chime in as we go along.
Sounds good. So Mac, why don't you give us just a quick perspective? You're obviously spending a lot of time at a console and working panels. So give us a little perspective of why, what are you seeing happen in the market right now?
Mike.
Gotta love live TV.
Yeah, gotta love live.
There you go.
It's clearly changing, and I think that was a big point of our first presentation, was how the world is going to be doing business going forward, and our production techniques are going to change. But for the point today, the wireless spectrum, as we should all be aware, has really been shaken up in the last few years, and RAD is offering a unique solution to that problem, and it's a way that's going to offer a lot more flexibility versus traditional systems in the world we're going to be living in going forward.
Yeah, you know what, you brought up the R word, and with that, the repack. I think I'll bring James on now to join us. With that repack, James, a lot came with that, right? We, for those of you who are been following RF for any amount of time, obviously James Stoffo is a name and a face that you're quite familiar with. But the repack, the licensing requirements that may or may not be happening in the future, even unlicensed spectrum. I mean, you guys, and we'll hear from Henry Cohen later too, you guys have been at the forefront. You've been in DC, you've been a part of these discussions, and we appreciate the job you guys have been doing with that, representing the needs of the production community, because there's a lot there. And while this is all about the RAD product, it's impossible to discuss RAD without also recognizing that this was a product that saw what we're going to be living in and what we are living in now and going forward. So with that, I'm going to turn it over to you and let your team go from here. And I think we're going to see and hear some great stuff and great questions.
Okay. First off, thank you guys, Kelly, Pete, Mac, because we're really making the best use of our time. We're all sort of stuck at home, and it's the most productive way that we can use this time right now, and I really appreciate it. We saw and you're right, we did start off because all of the owners of RAD, the founders, all have been in this industry. I'm going to introduce them all right now. First, Jeff Shearing's our CEO. He's online. Henry Cohen is here. He's an icon in the RF business. I learned a lot from Henry when I was just a young pup growing up. Ike Zimbel's here from Canada. He's our Canadian rep and tech support. And of course, Richard Stockton, who has been the sales and engineering person from Shure Wireless and then for RAD. And then a large customer, Cardinal Stadium, ended up purchasing RAD, and they hired Rich around from us, but we still maintain close contact with Rich. So these are all of my colleagues. We're going to do everybody a big favor. You hear enough from me last week and next week with the RF cage match we're doing. So I'm going to just do a little introduction and then turn things over for the other guys to handle the bulk of this. But let me start with, first off, the reason why we created Radioactive Designs. Now, all of us that you see on the top of that screen have been operating wireless microphones and intercoms for our entire professional careers. So right here on the top of that screen, there's well over 100 years of RF experience that you see here. And when we first found out about the potential spectral auctions and the white space devices and so forth, pretty much everybody up on its screen went to the FCC, spoke on behalf of the production community, the audio community, which includes churches, television stations, broadcasters, and special events, of course. And so this, by the way, we see who's signed online. I recognize a lot of your names. It's a really, there's no schlocks on this this webinar. We have a lot of pretty people. I worked with a lot of you over the years. So this is not a RAD sales pitch. You're already using RAD systems. This is for those of you who are using those systems to go deep into the source. Henry, Jeff, Rich, and Ike use these systems really deeply, and of course but I'm gonna more moderate when we get into the meat of this. So please, if you have questions, post those questions. I'll be looking at the questions after this brief little introduction, and I'll present the questions to Henry or Ike, Rich, who's ever speaking at the time during their segment. So please ask questions. This is about what you would like to know from us, not a canned speech of what we want you to know. We can only learn what you need by looking at these questions and addressing your specific installations and applications. We have people from right on the webinar right now listening that are using RADs in churches, in auditoriums, in theaters, in nuclear power plants, and space vehicle launches, all over, industrial applications, every bit of entertainment industry. So you ask the questions and we'll present the answer. So let me just fly through a little bit of some potential stuff here. So the reason, again, we created RAD, I'm going to go off my webcam. I'll certainly pop in when you need, but just so you can focus on the information and not on us. I'll be back when you need to see us. So the reason we did that, again, is because we were walking around, we heard about all these spectral auctions and so forth, and it became very clear to the founders of RAD that somebody needed to come out with a wireless comm system. Back in the early part of the millennium, there weren't that many systems out there. The DECT equipment it wasn't as, let's just say, as professional as it is now. And so we did this to basically for our own livelihoods. That first picture you see there of the UV-1G, that's the system, as most of you are aware. We use a UHF VHF scheme so that we increase our signal to noise ratio, and thereby we get better audio quality and range out of the system by keeping the noise floor down. All of the packs, as you know, transmit in VHF, TV channel 7 through 13, and pretty much in every city throughout the country, there are at least a few open channels, certainly enough to operate a couple of hundred belt packs. The modulation scheme is called enhanced narrow band. It's effectively it's a form of amplitude modulation. And again, the reason we did that was because the primary goal for us at Radioactive Designs was to build a product that was extremely, was spectrally efficient. Henry and I have been working as RF coordinators on large events for many, many years. And so the more spectrally efficient each device is, the easier it is to coordinate multiple devices into one area. And so that's why we wanted to go with amplitude modulation. You'll probably never see a wireless microphone with amplitude modulation because you can't get the audio quality required for an on-air music artist, for example. But it's perfectly fine for a communication system. Because it's enhanced narrowband and so spectrally efficient, we can put over 50 packs into one 6 meg chunk. Now, if you do the math, it should turn out to say about 120 packs because we're only occupying about 20K. But since we don't know of any one show where 50 packs were used inside of one television station, we don't want to make that claim until we go out and do it. I would like to get out there and try it so we can change that to a bigger number, but the fact is we're sticking to the facts. And with the people that are signed on to this webinar right now, you're keeping us honest because you're all very qualified, the names that I recognize. Now, this next quick comment, at the time that we developed radioactive designs, the Telex BTR system was the only other UHF system really out there on the market, and the Pro 850 from HME was also available somewhat. And so we were comparing what our spectral footprint was in the UHF band because all of the wireless microphones and in-ear monitors at that time were in the UHF band. Most of them still are. So in this case, that's how we're able to say you can fit 30 base stations, 200 belt packs in the same space as one 4-drop UHF FM system. And the reason for that is, again, because we use amplitude modulation. The end result, as a coordinator, as an RF operator, wireless mics, in-ears, comms, we clear up spectrum for all of these low-power auxiliary devices, which is how we are classified by the FCC. Incidentally, this is a very RAD-specific webinar. If you want to listen to the wireless basics one, Kelly could email the link to that. And I think next week, we're also doing, we're calling it a wireless cage match. Some of you that are listening right now are actually on that. And we're going to get deeper into RF in general, as opposed to just the RAD system in particular. The back panel we wanted to keep as close to essentially the unit that was the standard back in 2010, and that was the BTR 800, because we're going into installations where people already had multiple BTR 800s, and the idea was to make it a nice, easy insertion without a lot of new cable runs or having to come up with new connectors. Rich is going to get much deeper into the back rear panel, so I am not going to talk much about that now. The belt pack, pretty much the idea was Jeff and Henry and Ike and Rich and I, we've all used belt packs on shows. We still work on shows, well, not this month, but we have all our lives, and hopefully we will again very soon. And so we wanted to make this belt pack as user-friendly as possible and stick as much as far as operation goes into the pack. It does transmit in VHF, but it doesn't have a 3-foot-long antenna because it's an internal antenna, and we use the headset as a counterpoise, as a ground plane to that VHF wave. Each pack does have 4 talk paths, and again, Rich and Henry are going to get really deep into how that ties into your scene change, because using a scene change, you can have every single pack operate on any one of 20 different comm channels and 40 talk paths in a quick push of a button within just a couple of milliseconds. So before I turn it over real quick, here we see that since we introduced the company in 2014 or so maybe 5-6 years old now, since then we've been on all these great events. A lot of you guys have been on them all, pretty much Disney World, park-wide, all of the big broadcasts. The beauty of it being a software-defined radio means that as you give us ideas, to a certain extent, we can now go in and the engineers can rewrite code and a free download from RAD, and now you have a completely new system. For example, when we introduced the product on day one, it did not have a scene change function. Two customers within the same week asked us if we had the ability to quickly switch frequencies like a Shure in-ear monitor in Q mode, and we scratched our heads and the engineers scratched their heads, and we came up with a scene change, which enables one pack, again, to talk to 40 different paths and listen and communicate with 20 comm channels. And it was a free download. We put it up on the website, And now whether you bought pack number 1 or pack number 2000, you can download for free. And because it's a software-defined radio, we can continue to improve the operation based on your input. Just real quick, and I'm almost done with my part of this, is you can see here that a frequency modulation, any wireless microphone, any in-ear monitor requires at least 300 to 400 kilohertz of occupied bandwidth in order to sound great. And that's because it's FM. There's one static frequency in the middle, and it wiggles up and down over some amount. It might only be 75 kilohertz, but again, if you want to look deeper into it, because of something called Carlson's rule, you need basically around 3 times that to process that transmitter signal. And so that's why these receivers require 300 to 400 kilohertz. An FM transmitter should not look like that when you modulate. If it does, it's broken or overmodulated. The next picture there, that's our amplitude modulated signal, the narrow band, the enhanced narrow band signal. The reason you see 2 carriers, they do occupy 20 kilohertz, but it's a form of amplitude modulation called double sideband. So we require 2 sidebands, double sideband suppressed carriers. So as the audio is modulated onto the RF section, those 2 bands, if we were able to open that up and look in between them, you'll see the RF jumping up and down in correspondence to the audio. So I have one more here, and that is basically people always ask, well, what's the difference between digital and analog? And in this case, yeah, I put this up briefly when I had my wireless microphone discussion last week, and we saw a lot of questions come in after the fact, and I had a chance to answer those. And they were asking, well, what do you mean that this can't be coordinated? You know, RAD says you could coordinate, but digital can't be coordinated. What does that mean? That if I have an Axient digital or a Shure or a Sennheiser 6000 that I can't coordinate? Yes, you absolutely can. Those are wireless microphones. In this case, I'm comparing RAD's analog operation to the digital wireless systems currently on the market. They use various technologies. The DECT technology, the ones here in the US are all based around 1.9 gigahertz, 2.4 gigahertz, which is obviously Wi-Fi, and then of course the 902 to 928 band, which is a spread spectrum band. So those can't necessarily be coordinated to the point that we can if we have one single static RF transmitter signal. So in other words, my last big job as a coordinator was the Rose Bowl in Pasadena. You know, we have coach communications that are on 902 to 928. We have TV cameras on the field that are on 902 to 928. There are ref comms that are 902 to 928. And you can only pack so much of that into one area before they begin to collide and crash and run into each other. And basically the same effect as if you had too many wireless microphones that were analog in one area and didn't coordinate them properly, they would eventually step on each other. The difference is that with an analog system like the Radioactive Design's UV-1G, if you have a problem, you could tune around it. I was working at a church that had RAD systems. They put the base station up at the front of house console on next to a computer. Well, the computer happened to be stepping on a portion of the VHF band that they were trying to use. So we were able to fix that problem simply by retuning the frequency. That's something that you can't do using spread spectrum based systems. The other big difference is that in true broadcast fashion, an unlimited number of belt packs could be used off of one antenna. It's just like when you're driving in a big city with a million other cars, you could all tune your station to one FM broadcast station and listen to the same music. An unlimited number of packs could be used with one antenna, one transmit, one receive, of course. Whereas with a lot of the digital systems, you're either going to get loaded down, and Henry could touch a lot more on that, or you run out of range and have to hang multiple antennas to get the same number of belt packs to operate. The other thing is you can get priority by being licensed. If you have a Part 74 license, then you actually don't require it, but if you have a Part 74, then that gives you priority to operate a system like a RAD over someone who doesn't have a Part 74. With the digital systems, they're unlicensed, and it basically could be taken as being a free-for-all. As a coordinator, we do all we can to separate systems in free space, but we can't tune them. And so therefore no one could have priority. If there are two systems stepping on each other, it's not up to the coordinator to choose which guy gets to operate. Whereas with an analog system, and again, I'm talking wireless intercom, not microphones, although this statement applies to microphones. Even if you're my friend and you don't have a Part 74 and you're trying to use the same frequency as a person who comes in with the Part 74 license, and neither one of you could tune, the guy that has the Part 74 license gets the frequency, not you, my friend. I might go out and buy you dinner after because I feel bad, but by the letter of the law, as a coordinator, the person who has the Part 74 license is the person who has priority over the other operator. Because the system operates in VHF, and we're limited to 50 milliwatts as most VHF systems, but because the wave is so long, you get a great range. Out at one of the theme parks, we're getting like over 2,000 feet off of one antenna. It's, you know, close to a half a mile. And again, using the scene change function, which Rich will get more into, you can actually have each belt pack talk to 20 comm channels and 40 talk pads, because there's 10 presets. Each pack has 4 buttons, 4 talk pads, but 2 receivers for comm. The other part of this is lots of our customers are in the life safety industry, so it was really important for us to have a round trip side tone. Other systems on the market, all digital systems, as a matter of fact, have a local side tone because there would be anywhere from a 40 to 85 millisecond delay if you were to try to listen to your rebroadcast. What that means is that just because you're here yourself, that doesn't mean anyone else heard you. You know, when I put on a belt pack with my wireless, the first thing I like to do is take it for a walk and see what the range is. Can I make it to the restroom? Could I make it to catering? Could I make it outside to have a smoke, you know? And your pack is really going to sound great until it doesn't work if it's a digital system. Whereas with the RAD system, we wanted you to know your range. And so as you walk down a hallway, and us when we set up the system, or if your job is to set up the system, then as you walk down the hallway, you will certainly start to hear the noise floor creep up as your signal to noise and you approach your range limit. And so with that, Jeff, anytime you want to add in, please do. But at this point, I'm going to turn it over to Rich to cover the program, software, and the scene change.
Okay. Actually,
can you hear me? You want to go? You want to go?
No, you go first.
Okay, so y'all can hear me on your end?
Yep.
Okay. Let's see. So thanks for being here, and I'm really excited. And I want to, my main thing is I want to touch right off that I've been using this tool since 2015, and it is still my favorite intercom tool because I don't have to manage it. I don't have to worry about things going weird when I have no time to fix things or when I'm working on something else. To this day, I've had many proven times where I did not have to go and adjust the RAD setup because I did the proper work beforehand to set it up, obviously. But throughout today's presentation, I want to, make sure that that's a common. The common thread for me is that I've used many kinds of things throughout the last 6 years or so, specifically with wireless intercom. And again, the reason I like this tool the most is because I feel less stressed when I do my shows. It's the bottom line. So what I'll do, I'm going to just go through the front and back panel very quickly, but as we get further into this webinar, we can go into specifics on, for example, linking bases, setting up a third party line through the aux out or SA out, using the SA out for different types of output reasons. So here's the front. Can you guys see my mouse moving?
Yes.
Yes, Rich.
Okay. All right. So we basically here's 2 bases in a rack that I had for a demo rack, and they are linked together, but we can go over that later. But here's the LCD screen. All the receivers you could turn off and on, mute them. Channels 1 and 2 control, aux control, and stage announce out control. Here's the front panel connector or control for the headset connector in the front. That's it. So just to touch on this real quick, here's some other devices that help combine and split signals for receive and transmit out of it. We can get into that another time too. Here's the back panel. So let me switch. Oh, 1 second. All right.
Hey, real quick, Rich, while you're
Yeah,
looking
ahead.
for that, while you're looking for that, if you hold the talk button down when you power up the unit, it will power up in transmitter off mode, so you can tune around without stepping on anybody.
That's a good point. I have that on the video on the website that shows the basic setup, and that is part of that video. We are going to post a video on scene change soon, but there's a lot of features that you may not know about, and you will know after the end of today. So here's the back panel. So there, if you zoom out, there's 3 ports for BNC. Here it starts with a receive port. So your VHF signals are going to be received in here. The Ethernet port is not a functional port as of yet, but in the future it will be. And then you move on to the base link. For example, if you were to set up 2 bases where one's a master, one's a slave, the master will control the 2 bases together, but audio will pass out of base master slave into the next, the slave base. Here's channel 1. Actually, I'll skip forward. It'll go, here's channel 1 IO, 2-wire for RTS, AudioCom, and ClearCom, 4-wire for whatever 4-hour systems you have, frames or panels. Here's channel 2. Now we get into the other 2 ports are transmit ports. So now if I pause it, you could see the other port on the other end. So we have 1 and 2 separate for when you go into a combiner, an active combiner, because you don't want to have a combined transmit 1 and 2 into another amplifier, meaning you don't want to have port 1 used going into, say, an active TX8 combiner. That's why you separate them. And the reason is because it reduces IMD products quite a bit, and you would notice on the scanner if you did it the other way. So if you use the base standalone, you would put it in combined, and you'd have both carriers coming out of 1 port. Moving on, you have the input and output for aux. So along with stage announce output, you can use these outputs to create a flow of audio that comes back into the base to create a 3rd channel without having to use a matrix or whatnot. It's like it's an analog way of setting a 3rd channel. Let's see. So, and also the relay contact, if you wanted to trigger a GPIO for another device or another part of the system, you could use stage announce to trigger that connector there. Now the back is basically this, but there can be there's a lot of questions on connectivity, which if this is the right time to bring you in, Henry, you can talk about that.
Sure, we can go to Pete. You want to switch over to my screen?
I'll stop sharing. There you go.
And let's see.
You got it.
All right, I'm just gonna get the right. Hey, I just make sure I pull up the right. Yeah. All right, so talking about connectivity, a lot of this will be familiar to you if you're used to a BTR 800 from years past. It's, again, designed pretty much to be drop-in. So here's an overview of the back panel. Rich went over most of this with you. There's a few specific things which aren't immediately obvious, which we'll continue on. This image, by the way, is in the manual, if you want to download that. It's on our website. So the first thing is, let's discuss BaseLink. This has several permutations that can be configured based on what you want to do. The most important thing is that when you use a BaseLink, it must be a shielded Cat5 or better cable, and try to keep it under 12 inches. The reason for that is BaseLink is transporting clocking. We do need that ninth pathway of the shield, and because of the clocking timing, we want to keep the length of the cable below 12 inches. In reality, we've had people use 24 and 36-inch cables when they've only been using 1 or 2 base stations, and it's worked fine. We've had people who have not been able to use shielded Cat5 because when they're racked together, the frames of the equipment are bonded somewhat through the metal screws and the rack rails, although it's generally not the very good way to pass the ground. So we certainly recommend using a shielded Cat5. If you don't have a shielded Cat5 and you don't have these items in a rack, you can go over to the ground bonding screw all the way to the right-hand side of the rear and just run a quick piece of bonding wire between the frames, and that'll get you your shield connection. With the BaseLink, the important part to remember is that it's carrying clocking, and in the case of master-slave mode, it is also carrying the intercom audio back and forth, and I'll explain that a little bit more. The stacked jacks you can see are labeled BaseLink in, BaseLink out. When you connect a Cat5 to the top jack, the in, the base station now knows to turn off its own clocking and receive the clocking from the unit prior. Whether or not you're in a master-master mode or master-slave mode, and again, I'll get into that, the in port is to turn off the internal clocking. The base out, the link out port is to pass on the clocking. So in typical fashion, if you assign your first master, you will want to come out of that master and then daisy chain through all the others. Another hint, if you have a linked system and you are powering up or power cycling the system, always turn on the master or the first unit first. Wait until the backlight on the display comes on, then turn on the successive units as they're linked going down. It just helps prevent any clocking mistimings and units firing up before they get a good clock signal. As far as the number of bases you can link a maximum of 6 base stations. You can have 6 master-masters or 1 master and 5 slaves, but 6 is the limit. And again, we recommend a link cable no longer than 12 inches, but if you're going to be using less than 6 base stations, you can get away with a slightly longer link cable if that's all you have. So let's look at the 2 ways you can actually link the units. The first is a master-master mode, and that's where all of the base stations remain in master mode. And this allows the belt packs to talk to any base station, to talk back to any base station on each individual channel. For example, button number A could go to base station number 1, channel A. Button number 2 could go to base station number 3, channel B. Button number 3 could go to base station number 4, and button number 4 could go to base station number 6. So this allows for bell packs to talk back to individual base stations and to listen to 2 different base stations on their intercom channels. When you're in master-master mode, the only information going through the link cables is the clocking. The second configuration is master-slave, something we're more familiar with. Same concept, you're coming out of the master and going into the slave and linking down the slaves. The master-slave is basically when you're interested in only having more than 6 bell packs on the same 2 channels of intercom. In master-slave mode, the slave base stations have their transmitters turned off internally. They're all relying on the master 2 transmitters to send out, to broadcast the information. However, you still need to feed receive to each of the individual base stations, the receive RF. So that does not change. The base stations still need to receive a split off of the antenna. But transmit-wise, only the master will be transmitting RF.
Henry,
Yes.
so Nat Corin asked, if it's analog, what's the clock used for?
Good question. So the clock is being used for 2 things. Number 1, these are software-defined radios. So it's not a typical analog RF stage where all you're doing is feeding a reference crystal. These are software-defined with a master clock inside, in addition to which the audio is going through a DSP. So that also needs a clock. And we're therefore passing the clocks between the base stations so they are synced. Hope that clarifies that. Thank you for asking. Back to master slave. The other part is in master slave, the audio from the 5 slaves or up to 5 slaves is being passed back to the master through the Cat5 link cable. So you don't need to link the audio side. That'll occur through the Cat5 connection. In the master slave mode, it's only the 2 intercom channel audios that are getting passed through the Cat5 link cable. If you want to access the aux out or the SA out of each individual base station, you must in fact connect to those individual base stations. So that actually gives you more output points and creates additional IO for a master-slave configuration. In the master-master mode, each individual IO of each base station is still active and you must make those connections. On the one hand, that may be more laborious and more tedious in your connectivity, but it's the way to gain additional IO. So if you have many different program channel or many different intercom buses that you need to transfer to wireless intercom, that's the way you increase your IO. And by using the master-master link mode, you don't restrict your bell packs to only a given base station. Any bell pack can talk and listen to any multiple of base stations. Moving on to the actual audio connectivity. As Rich showed before, we have our standard 2-wire intercom connections, a male-female pass-through. They can be configured for the 3 primary 2-wire intercom standards that are still in existence today. They're selectable either in the menu on the front panel or through the PC software. Next is 4-wire connectivity. We do that through an RJ45 Ethercon jack because we're running out of real estate to put XLRs, as do most manufacturers today. As you can see below, we give you the pinouts for all the various frames and other manufacturers, as well as the XLR breakouts. And if you notice that RTS, it's a direct connection. And again, that was because we tried to maintain compatibility with BTR as a drop-in replacement. James, you look like you're ready to ask a question.
Yeah, actually, this is from our friend Andrew McCadad. He says, without a unit in front of me, I'm a little handicapped, but as I've experienced in the base unit, when the 2-wire intercom port is selected, at the moment of the press of the 2-wire button, the converter is also nulled. Do I have that correct? And if so, is there a way to keep the nulling fixed?
Well, the nulling is actually occurring on an automated basis, and it's happening behind the scenes. I don't recall what the interval is, but it's happening subaudibly. So there's no manual nulling. It's going to take place on its own.
And
Hey, Henry, I just wanted to quickly point out that the RJ11 4-wire breakouts that have been in the industry forever will actually fit and work in the middle 4 pins of the RJ45 jacks.
Yes, I was going to say that you can actually very carefully insert the RJ11 plug into the center of the RJ45. However, we don't recommend that because without the adjacent pin receptacles of an RJ45 plug, the pins may not align perfectly and you may find yourself shorting out on either pin 3 or pin 6. The jack, the plug isn't very secure in there either. So it's not recommended, but can certainly be done in a pinch.
Hey, Henry, so Pete Erskine is asking, I'm assuming for everyone else's benefit, I hope, with RTS, how do the 2 channels come in?
I'm not sure I understand the question.
I think what he's trying to get at is we only need 1 connector for 2 channels on RTS to the base unit.
Yes,
Oh, well, that would be
Henry,
back.
if I have a 2-channel RTS, 1/2 plugged in,
Oh.
can I just plug it into any jack if it's in RTS
Yeah,
mode?
so when you select RTS 2-wire mode in the software, again, just like with our friend the BTR, all 4 jacks, all 4 of the 2-wire jacks become paralleled connections. However, internally, channel A will pick off the pin 2, and channel B will pick off channel 2, which is pin 3. Does that answer your question?
Sure.
So getting back to 4-wire, this is the pinout for just about everything that you're going to see on the market that has a RJ45, or at least that you generally see in North America. I know there are some other brands of Intercom in Europe. I'm not too fluent with those, but we give you the pinout over here so you can make the translation easy enough. And then just keep in mind that when you're looking at the Ethercon jack, pin 1 is going to be on your right and conforms with the 568B standard. One note about gains. On the 4-wire side, the gain is really digital trims. It's not an analog gain stage the way we generally think of. So it's best to set your gains at the matrix nominally to a +4 dBu, and that will prevent a potential overdriving of the inputs into the RAD. And an overdrive of the RAD will manifest itself in dropouts, audio dropouts, not RF dropouts, but dropouts nonetheless.
Henry.
Yes.
Gary Trend is asking, what's the reason I would need to sync master clocks between two bases if you're in master mode?
Oh, as I said before, that's so bell packs can talk and listen to multiple base stations simultaneously. So for instance, if you wanted to listen to, on your bell pack channel A, you want to listen to A of base station number 1, and on the second channel of your bell pack, you want to listen to channel B of base station number 4. That allows that. At the same time, you can now talk into different base stations based on what button you press on the bell pack.
Henry, so Dave Zammit is asking, can you interface ClearCom 2-wire?
Absolutely. So you'll connect the 2-wire to the 2-wire ports, and then you'll select ClearCom in the software or on the menu.
And we have one
But
also.
what if it's?
I think Sammit's
Intercom TW line,
Right,
which
TW.
is the same as RTS.
Oh, ClearCom TW, yes, same as RTS.
So Henry,
However,
Jeff Jones.
Are a little,
Yeah,
I think the impedance is different. I'm not sure how well the RTS mode would gain stage with the ClearCom TW mode, but I think it'll work, and I think it should work within the game.
Jeff Jones is saying, having multiple base stations, does that allow more 2-wire and 4-wire connections outside the RAD world, having 2 to 6 total base stations?
Yes, as long as you stay in master mode. Then with master mode, you have full connectivity and full I/O of each individual base station. Any other 2-wire questions?
I think that's it. Yeah.
Okay. Back to 4-wire. Any 4-wire questions?
Not at the moment.
All right. We'll dig in a little deeper now into the transmits, as Rich said before. So there are 2 transmitters in the oh boy, in the RAD. We can either have them in a combined mode or a separate mode. In combined mode, what would happen is you would take the switch, put it to the left-hand side for combined, and then both transmitters will be combined out port number 1. If you're simply going to a singular antenna, or you are in a master-slave mode, and you're going to send out through only one base station, and you're going to go to a single antenna or even multiple antennas through a split, you would want to use combined mode and use the single TX1 port. If, however, you need to separate the 2 transmitters into separate ports because you're going into a active combiner, then you would put the switch over to the separate mode on the right, and then you would have transmit 2 and transmit 1. Internally, the base station will make up for the power loss of the combined stage of the combiner when you're in combined mode. So if you select a given power level on the menu, you will get that power level out per channel regardless of whether you're in separate mode or combined mode. We will take care of the power compensation internally. Any questions on transmitters?
Yeah. Our friend Jeff Jones here is asking, is there any benefit to using the separate TX mode with only 1 base station and 2 antennas?
Not that I can readily think of, because it's not as if the 2 ports are duplicates. One port is going to be channel A, one port's going to be channel B. And certainly if you have 2 separate antennas, now you've got to deal with making sure they're in each other's far field, and that they're both covering the needed areas for the 2 channels. I would think in that sense you're better off combining the both channels into the 1 antenna, and then if you needed to, split that antenna, unless I'm misunderstanding his question. Uh,
Just
and then
first,
what was that?
I'm sorry, real quick, can you go back and say it one more time? For Frankie Castro was asking, how long can a link cable be to pass the word clock properly, as some companies have their base stations really deep in racks?
We recommend no longer than 12 inches for a link cable. However, that is based on a maximum of 6 base stations being linked. If you have fewer base stations, you can use a longer cable. I've seen people use certainly a 24-inch. I think I might have seen them use a 36. I don't recall. And they were only linking 2 base stations and they were working fine. Mac,
Yeah,
you look like your voice.
Yeah, I think, Henry, there was some confusion with sync and word clock. He was asking about word clock, and there's no word clock involved here, as far as I know.
Oh,
Sync,
correct.
sync is syncing clocks within the units.
That is correct. We don't take an external word clock, the 75 ohm word clock that is used in the audio world. This is just our own internal clock syncing. Pete,
I think the question from Jeff Jones was, is there any benefit to using 2 separate transmit antennas on a base in non-combined mode, as opposed to using a single antenna in combined mode?
Right. I can't think of any, because you'd have 2 separate intercoms going through the two separate intercom channels, one in each antenna. They wouldn't be combined. So I'm not sure I would see a place where you'd want to feed one intercom channel but not the other in a given zone. But I guess that's a possible scenario. Jeff, if that doesn't answer your question, email me later and we'll hash it out. I may be missing something. All right, and as far as the receive side goes, no matter what, if you have an active base with active receivers in it, you need to feed it an RF receive antenna signal. So you will need to have an RF splitter, whether it's an active multicoupler or a passive splitter. From your receive antenna, you will need to feed each base that's in use. Of course, the advantage with VHF on the inbound is that the coaxial losses are so much less through your cable runs. You can generally afford to use a 4-way splitter quite easily where you would otherwise not on an UHF band. Any RF questions? All right.
Yes, Henry. Jason Glass is asking, how close can the transmit frequencies be in high power mode?
I've had them as close as 75 kilohertz for 250 milliwatts. That was certainly in the oh shit, we've run out of spectrum. I prefer to keep them closer to 100 kilohertz apart. I've run 90 and 95 kilohertz a lot as well, but I've had instances where I've gone down as low as 75.
Henry, there are a couple of questions actually coming in. Jose Moore is asking, can the TX outputs be combined in a combiner, like the TX8, for example, that's also being used for in-ear monitors?
Yes, absolutely. You can absolutely do that. Again, following good combining protocol about making sure that your greatest frequency separation is occurring with adjacent input ports on the combiner is always advised. And you'll want to make sure that your combiner actually can take, if you're not using a TX8, and you need to rely on the transmitter's power output to get the power output you want out of the combiner, you have to make sure that the combiner can actually take 250 milliwatts. We found very few that can actually take it and remain stable.
Jason Glass is asking, does the power level change the recommended freak spacing at all?
Yes, you would want, I don't have a firm spreadsheet, but yes, if you're going to do 250 milliwatts, I would probably keep the spatial separation or the frequency separation closer to 100 and a quarter. But I've gone down to close as 100 kilohertz for 250 milliwatts.
Wow. So there's quite a few questions rolling in here for you, Henry.
Sure.
Jose Sanchez is asking, can the 4-wire interconnect with a Clearcom Helix net, and how many channels can you link?
Well, if you want to go to HelixNet, and Pete, you'll have to correct me here, I don't believe HelixNet base gives you the ability to flip the 4-wire port to choose between panel or matrix. So what you will need to
No,
do,
you've got to have it wired properly to do that. The FreeSpeak port does that, not the HelixNet port.
oh, okay,
However, if you're using an LQ on your HelixNet, the LQ does have the flippable 4-wire port.
oh, okay. So then what you would need to do, whoops. So then what you would need to do for HelixNet is reverse these for the IO. And then follow your pinout. So I guess for HelixNet, I can add that into the matrix at some other time before this gets posted. So obviously you'd want to do you'd want to flip 3 and 4 and 6 and 5 for HelixNet.
Okay, Henry. Andy Cross is asking, do I need a separate VHF antennas? Do I need separate VHF antennas for 2 units, or can you use a split into 2 units from one single antenna?
Oh, you can absolutely use a single antenna and then split. I do passive splits up to 4-way with very good results. Or you can go into a multi-coupler. There's a couple of that handle VHF on the market now, including ours.
Chopper's out there. He's asking, what's your recommended cable model and type for the VHF side?
My default is always a 0.4-inch double shielded 9913 F7 LMR 400, the PWS variants, the Ecoplex, and was it the 8946? Sorry, I don't remember the number off the top of my head. That's just always my default coax. It's big enough not to get some respect from people in terms of handling. It's a good low loss, and it doesn't take up a tremendous amount of room. However, if you're going to start running 500-600 feet, you may want to think about moving up to an LMR 600. If you're only going to be running 50 feet and you're really tight on space, or you have to go into tight cable trays, an RG8X double shielded like an LMR 240 is a perfectly good option.
Ike, you have something to add?
Yeah, Henry, a question mirroring Jason's question a little bit, but on the belt pack end. Does the 10 milliwatt versus 50 milliwatt power output on the belt pack affect frequency spacing?
Not that I've noticed. And in fact, most of the time I've kept belt packs in 50 milliwatts, only because users tend to go to places that you were told, oh, no one will ever have to go.
Yeah.
I got a couple here, Henry. Jamie Easton's asking, will we be covering the connection to the TX8U at all?
Yes, we'll touch on that briefly. We'll touch on RF interfacing. I have some more to show, but let's get through these questions first.
Yep. Stan Dickerson's asking, is there power on the antenna connector? I'm assuming he's talking about the receiver antenna for a remote amp, for example.
No, we do not provide bias voltage.
Derek Menigan, I'd love to have a better understanding of the combining antennas in general. Do you have a link or suggestions for a base understanding? And
Combining
there are quite a bit. Yeah,
combining antennas or combining transmitters?
He says combining antennas in general, but I think this is one we'll cover for our cage match whenever that, I think it's April 30th.
Yeah, I think we'll dive far more deeply into DAS and other tricks on that.
Okay, and then finally right now, Jose Sanchez, at the current time, is the last question on the map, but how many packs can one base station handle?
Okay, so, and Rich will get into this. Each base station can handle up to 6 belt packs. The base station is designed in a modular format internally. So they're a fully a fully configured unit will have 2 transmitter modules and 6 receive modules. However, you can order the unit with as little as 1 transmit module and 2 receive modules. And if you want to add more later on, you unscrew the 10,000 screws that hold the top cover on, and then you carefully, and make sure you're statically discharged, insert the additional modules that you've ordered, and close her back up, and you're on your way. Now, that said, because this is analog broadcast, you can have an infinite number of bell packs listening, but you can't have an infinite number of bell packs talking back in, though. And that's because of the fact that the bell packs are actually transmitting all the time. They're not in a push to transmit mode, but you can set the software so that a bell pack has a disabled transmitter, and obviously then it can act as a receiver, and you can have an infinite number of receivers.
Hey, Henry, are the belt packs tied to any single base, or can you use any pack with any base station?
Well, if you're not using the base link, then a bell pack is tied to a given base station. Once you use base link and the master mode, that's when you can have bell packs associate with multiple base stations simultaneously.
Okay. And
James,
here's
could I answer that a little bit? Just to clarify, so the bases and the packs are tied together through frequencies. So as long as you set your frequencies on your pack to match your base, then you can, obviously, if you change your frequencies, use it with any base you have. So there's no, because they're wideband tuning, any pack will work with any base if it's tuned to those channels.
okay.
I was gonna say I can go through that in the next part here.
Okay.
Base to base.
Win Johnson is asking, can you double pack the RAD like you can the BTR if there are not critical operations? In other words, have multiple packs on the same receiver channel, for example?
Yeah, unfortunately, no, because each bell pack, assuming its transmitter is enabled, is actually transmitting all the time. So it's sending back a heartbeat to the base station. That's how we get the telemetry off of it. So you can't stack bell packs with a transmitter.
I've had to humbly disagree. I think I've had luck doing that, where you've had multiple people listening, and as long as the people aren't transmitting at the same time, as long as you got some comm discipline where they know that it's a kind of a simplex operation, then you can get away with more than one bell pack on a channel.
I stand corrected. I don't recall having much success with that.
Yeah, if you do that, though, the only thing to keep in mind is that if there's a battery dying on a belt pack and it sends a battery dead signal and the base station light turns on red, the next guy to key up's got a good battery and it'll turn green again. So you'll never know the one pack's got a bad battery.
Right, you don't know whose telemetry you're looking at. All right, we'll move on from here. So we covered the transmitters. This is just a quick picture of a very intricate master-slave linking. This is the new intercom system for Saturday Night Live and NBC Studio 8H at Rock Center. So what you see is almost every pair is a master-slave. And then there's a couple of master-slave-slaves, and then a couple of master-master links. I don't recall exactly. And then there are numerous TX8s because there were 12 zones of coverage in the building for the production.
Hey, Henry, a couple of more questions pouring in here for you.
Sure.
So Brad Galvin wanted you to, again, could you say again what information is going between the base station on the link cable in master-master mode?
In master-master mode, the only thing that's occurring is the internal clock sync. So any base station that has a Cat5 cable connected to the in port has its internal clock turned off and is receiving clock sync from the prior unit. And then the unit that has only a Cat5 connection to its output is the master clock unit for that system.
Here's a really good question too. Gordon Nemo Smith is asking if the headset's part of the antenna for the belt packs, are there better or worse headsets that you can use I'm assuming to increase or totally destroy your range, like the new small headsets with an inline electronics built in, for example?
Very, very good question, and I forgot to discuss this. You do not want to use a headset with a coiled cord because the headset cable is acting as the antenna. Using a coiled cord is detuning that antenna. So that really is the only caveat that we have found so far. That said, somebody did rewire one of their headsets with the Canary Star Quad cable, and that didn't work very well.
What about the small ultimate ear DPA headset combinations I'm seeing that have the electronic circuit with the phantom power? Would that affect the antenna's range?
I don't recall, but I think Jeff ran into that.
Question, doesn't your microphone jack provide phantom power for the mic, for electret mics?
It does provide bias, yes.
But why would you need to put the box in there for you? Like for the in-house antenna, I don't use the transmitter, the power box when I'm using a RAD. I just plug it right into the belt pack. It works fine.
So Ultimate Ears has this miniature, they use in-ear monitors and a DPA miniature headset, and it comes connectorized with a microphone connector and an actual 1/8 inch mini out for the headphones, and that connection that takes the two wired connections and marries them to the XLR 4-pin or 5-pin has electronics in there. And I believe that's to bias the mic and to give some amplification to the headphones.
Yeah, in the in-house, it comes out to a 6-pin T connector, and then they have a T connector to various configuration of 4-pin, 5-pin XLRs. But then they have a separate box to go in the line if you can't get phantom power with it AA in line. So I think it depends on the headset whether or not it has extra electronics in there. As long as the cable is one piece of wire going all the way up to your headset, that's what you want.
That should work fine.
Well, I would think that if there's electronics inside, that's going to break your RF connection from the belt pack to the headset wire.
Well, but it depends on where the electronics is. If you've got at least 14 inches of cable coming off the XLR before you hit the box.
Right, so the box.
I meant not using the box in the case of in-house headset, which you get the bias from inside. Yeah. Without using the box, it's a problem. And the box usually is just a AA in line, no other electronics. It may not even affect it.
James, I'm not familiar with the one you're mentioning, but all the other ones I've tried work fine.
Okay, great. So Patricio Ramirez from Chile is asking, having the antenna, because we have
Patricio!
Yes, Patricio, hola. Having the transmitting antenna inside of the circuit of the belt pack, doesn't that cause a problem with our transmit power?
Not at all. We remember that you've got the transmits in UHF and the base station transmit, the receiver in the pack is in the UHF band and the transmitter in the pack's in the VHF band. So you've got at least worst case scenario, you've got 250 megahertz of frequency separation, which is more than enough attenuation from the UHF, from the VHF side into the UHF transmitter receiver.
We're getting a couple more questions in, Henry, that we need to address while we're on this topic. Which headsets are the best we've found to use with the V2 version of the belt pack?
Well, I think that depends on what you need in terms of noise.
Our new RAD headsets work great.
The new RAD headset, yeah, exactly. PH88 we found works very well. The The David Clark's were working well. We did have to make some changes to work with them, but they're working well now with those. And
The shores work well. The shores work pretty well. The shores.
Oh, the shores work well. Bayer DTs.
I think of what else.
Hey, Henry.
Yeah.
We just heard from Ryan Trefethen, and it sounds like if your belt pack has bias power, you do not require that external box. It's optional for comm systems with power on the UE headsets.
Oh,
also,
perfect.
Yeah.
Thank you, Ryan.
Yeah.
All right, so. So here's a couple of schematics for systems that we have deployed, actually Rich deployed. As you can see, you can have completely independent RF paths being combined or split as required. In this particular installation, we have RF over fiber for some zones coming in, as well as a direct connect using a PWS DBIC. So here's one example. Oh, and referring to one of the questions before, in this particular installation, there is an IEM transmitter in the same transmit combined system as the RADs. And then similar vein, here's another version going into a TX24, which is a 2x4 splitter designed primarily for very low signal level output for fiber transmitters, as well as standard antennas. So we still give you all the versatility you need in order to facilitate a full distributed antenna system, as well as a full audio matrixing of I/O. And with that, if there are no more questions, I'll hand it back to Rich.
Yeah, there are quite a few actually, but Rich, stay on the line. You can help with these too. Dave Condi's asking, do these packs work with the Bose headsets that have the noise canceling box?
Yes.
And
we use the 30s and the 40s we use at the stadium there.
Oh, great. Oh, you're putting those to use. Good. I tested those out at NAB, and they sounded really quite good. And they quieted everything down. For noisy environments like a music show or a football game, they're perfect. Joe Sanchez is asking, what's the price point on the RAD headset?
Jeff may want to answer. Or Ike, maybe?
I know it's under $300. I know that.
Yeah, I'll look it up in a second, but I just wanted to mention something about the noise issue, is that we also have the filtering on the microphone input on the pack now to lessen the bandwidth for high noise environments.
That's great.
Yes.
Andrew Herbine is asking, I have a custom headset. He's got using in-ear monitors headset, and it's feeding back. He's using a RAD belt pack in one ear, and it's going to Electrosonics IFB in the other ear, a shared ground. Any suggestion to prevent the RAD feeding into the Electro pack?
Can you, I'll tell you what, why don't you email me exactly the part numbers you're using and the wiring diagram, and I'll take a look at that tonight or tomorrow, and I'll get back to you.
Scott Sachter's asking, for headsets, how does the Riedel run and air? How does that work okay with our stuff?
I'm sorry, I didn't get the question.
Does the Riedel run and air work with our packs?
Oh, I haven't tried the Riedel headsets, but since they generally follow the same impedance, nominal impedance values as most of the other headsets, I don't see why they wouldn't.
I've had issues with them actually.
Oh, there you go.
Yeah, so I compared the HR1 or HR2 compared to the Riedels, and it wasn't quite the same. I didn't get further into it, but sounded a lot thinner. But maybe it was a different run of it. I don't know. But this was a quick A/B day when I did it twice, and they both had the same result. So I'd have to investigate further.
We have a comment from Francois Lantin. I believe that's Francois from CERC. He said the Sennheiser HMD26s are nice and loud. So he's recommending we use the Sennheiser headset, and certainly in a noisy environment. And Loren Sherman is asking, Henry, why does the coil on the headset mess with the RF?
That's because you're shortening the antenna and detuning it. And the coil is also acting almost in the same manner as a twisted pair, in that the coil of the next coil are interfering with each other in terms of the length of the radiating face of the antenna of the radiating element. It's curling into itself.
So it's not like a helical antenna where we're getting a benefit from the coil. This is actually canceling itself out because it's not designed as an antenna.
Because it's not tuned. Now, if you could stretch that coil out to the right wavelength and the right diameter, then yes, you could get a helical antenna, which would then be very directional.
Yeah. Jeff Jones is asking, what are the fiber line limiters in the diagram we're looking at?
Limiters. Those are just RF limiters. So if somebody invariably keys up a walkie-talkie right by an antenna, you don't blow out the fiber transmitter. It'll still sound like caca, but at least you won't blow it up.
All right, thanks. Gary asked a similar question about the internal antenna, and the antenna relies on the headset cable. Can you explain a bit more about how the antenna works and why a coiled headset causes a problem? But I think you just did. And Chopper is asking which model of RF fiber converter pairs are in Rich's diagram.
So those are the version 2 of the RF venues piece. They now have version 3, I believe they call it. But at the stadium where I work, we use Summit's version, Summit technology. With the PWS one and the Summit one, you could stab it with a USB and program it on a network. And there's also the benefit of those two is that you could put an amplifier on the fiber side, and you could attenuate on the RF side as well. So they're very versatile. You could basically fine tune it just like you would on your audio console. You could fine tune it the exact way you want the signal to come in and go out. So the picture, yes, the pictures are the older ones, which are not made anymore.
So that's it for the questions at the moment on the board. Thanks, Henry. And of course, hop in whenever you want.
All right, I'm handing it back to Rich.
All right, so I'm going to jump into, we talked about routing and doing, getting multiple channels out of the RAD system. So I've narrowed it down to 3 different ways to create more channels than just the 2 PLs that are on the base. So here's the system at the stadium here. So I have 4 RAD bases. On base 1, I have 4 packs that can bounce between all 3 bases, and that's doing it through scene change. The middle 2 bases, I use the aux out. For example, I take, one second. Oops. I take an aux out, go into the aux in of base 3, for example, and I tell that base to put it on either 1 or 2 channels, 1 or 2, and that output is triggered by button 4, for example. So I could assign button 4 to push audio out of here, go into the 3rd base, and they receive it on their channel 2, and I do the same thing for base 3. So the scenario is, and I'll go back. these two bases don't have their own PL. Like for example, stage manager does not have camera, and camera does not have stage manager. So I want them to be able to talk direct to each other without it going through the wired side, and without them having to pick up their cell phone to talk to each other. A good example is the stage manager is looking for cameras, the wireless cameras, and they don't know where they are. They could punch up button 4. It goes into their base. It transmits out to whatever channel you decide, and they can respond back. So again, that's just going back to the back panel and routing audio in and out of the aux.
Hey, Rich.
Yes.
Just maybe you could explain to people that what you're doing is basically leveraging a very powerful routing matrix inside the base station, where you can assign talk paths to buttons and buttons to talk paths and that kind of thing, and that's how this is all happening. It's not just plugging the jacks in and out on the back. It's actually going into the base station, into the programming, and saying, when you push this button, this is where I want the signal to go.
Yeah, and so that's a great way to lead into the app. So here's the app.
Rich, real quick.
Yes.
We had Roger Gonzalez was asking, first off, was the prior diagram, the schematic diagram that you had up, was that your installation that you're going over now? Is it possible to elaborate on the goals and objectives of the deployment that was on that graph to get an idea of what devices or elements are used and why for that particular application?
Okay, so do you want me to show the graph again?
I think so, yeah, please. And if that's your installation that you're showing pictures of, let us know that too, and what your goals were in that design.
Okay, 1 second. So what I just went over was the communication between base 2 and 3, and I could show you on the app how that's routed. You can route this in the base station and the pack without the app by going through the menu and choosing what receivers do what and what transmits do what and what buttons do what. So for this rig here, though, my idea was to get a complete second zone of the main system that incorporates 3 RAD bases and 1 1000. So the routing I just went through is part of that, yes, but part of the other system here is to get a complete second zone. So like I could show you a picture later, but I built a fiber rack which has all the Summit sets in there and the passive equipment in there that takes 1 antenna to transmit out and then 1 receive antenna. It's all connected, meaning I could walk a pack from every one of these systems here, go to outside the building to where this system's at thousands of feet away, and still have everything work. If you look at further into this diagram, though, this shows that I have more receive sets because the benefit of this RAD system is that when you transmit out of this with AM and AM signal and the range that you get automatically right up front means that you'll most likely only need 1 transmit antenna. For example, this antenna here is in the bowl, it shoots at the 50, but this zone here is in the bowels of the building right behind and underneath the the transmit antenna with all the cement and seats in between. And all I need is 1 receive over a fiber set. So I enhance that zone by adding 1 receive. And this area here is another, it says on the north end, in between all the cement and everything too. So the benefit of the RAD is when you need to expand, say for example, you're a stadium and you want to go deep into a VOM, most likely you just need to put a receive in that VOM. The transmit will be penetrating enough so you will get good signal on your pack. You're just helping the signal go back to the base station. That's the whole idea about this. Now, again, this side with doing all the transmits is an extreme situation where I can't cover everything with one antenna because I'm 2,000 feet away outside of the building. If that makes sense. So I'll go back to the app. So I want to go over this quickly, but as much detail as possible. So if you notice, the app has two tabs. This is where organizing is key, because if you don't write your frequencies down on a spreadsheet, or you, like, for example, I can go back to my this is IAS. Oops, one second. I'll have to go back to that. I use IAS to see all my numbers in an easy form. IAS is a coordination program made by PWS. Another way that I organize frequencies is I just made my own spreadsheet, and I just started making a custom spreadsheet where I have all the packs, their numbers, the receives on the packs, up to all the base stations that I use. Now I could quickly go, okay, what was that number I used? Okay, it's right there. And I go to, I look at this, and then I go back to my RAD app, and then I start entering numbers. So on this file, I'm going to show you how to do the other two sets of scene changes. So again, to get more channels, you can use routing in aux or SA out and go back into the base. That's a way to get a third channel. When you do base to base, without, for example, if you do all master bases without a link cable, you can have any number of packs listen and talk to each other base. The reason you use a link master is when you're cross-tuning. Cross-tuning is a way to get a pack to talk to one channel of one base and one channel of another. So for example, if I go to the belt pack configuration, this is where you're actually programming the pack to do exactly that. So for example, this is a pack on audio base 1. I want to create a scene change that actually goes to base 2 only. So if you look, the numbers match exactly what base 2 is doing. And I could create the labels to match exactly. Now, and this is the cross-tuning. Cross-tuning means that I'm taking one button of my pack to go to base 1 and one button of my pack to go to base 2. Now, the trick to this is that you have to, it's beneficial to open up a receive channel on your base to accommodate a cross-tune. So when, now I'll go to this video because it actually shows it pretty well. Let me get there.
And Rich, this is all available on the website. If anybody wants to watch it at any point, it's on the website, correct?
Yes, and it could further explain it if I can't get to it today. So if you watch the background, if you watch the LEDs on the receivers going, I'm demonstrating a pack tuned to one base, a pack tuned to both or to another base, and then a pack cross tuned. So here's a pack that's tuned to the first base. Now here's the second base. So you see the light on there. Now I'm tuned to both bases because right now I'm cross tuning, and the video will show you here. I'm going to jump to the pack here. Watch the pack. I'm going to go to my different scenes. Here's scene 1. Here's scene 3, which is SM over show. I'm hitting only one base right there. Now here's where I'm hitting both bases. So I'm talking to channel 1 of base 1 and channel 1 of base 2. Again, that's the cross tuning master link setup. The trick to cross tuning is, if you notice, when you configure your base, when that pack hits the base 1, I want it to only send audio out of channel 1 to the rest of the system. I don't want my transmit from the pack to go out of both channels because again, I'm sharing frequencies. It may be hard to see it here, but if you look at the base tab, I'm sharing frequencies with a receive that's on both. If you look at base 2, this receive would be on the same channel. And again, to see it, you'd have to, like, here's the other file. So here's the other receive and belt programming. So I'm showing, one second. Okay, on the base, when I transmit to the base from the other pack, it's not coming out of channel 1 of this receiver. Again, the scene change video and the setup video on the website shows, that section shows exactly what happens when I do scene changes and how it affects the receiver. So the easiest thing that I do, for example, if I go back to the picture of the setup that's at the stadium, is most of the time I do a base-to-base scene change. So my 6 packs on this base, I have 4 of them programmed to bounce between these other 2 bases, or actually these 3. So belt pack 1, I do a scene change that's labeled SM. It talks to this base, and the thing is, you have to remember that when you switch to another base, you start to stack frequencies. If this base is full, the pack that switched over needs to remember that, hey, I want to pick a receive channel that's not being used to talk so much. So I'll send back pack 1 to 6 on here when I switch over. And most of the time, it's just, for example, the lead A2 or the field A2, they want to just be able to listen to what the stage manager is saying. They don't need to necessarily talk to them. But it's very handy. It's very handy that the lead audio tech on the field can troubleshoot and hear anyone's conversation. That's the main idea between base-to-base scene changes. So again, this example, this file incorporates both base-to-base and cross-tuning right here. And if you need further explanation, I could dive into it more. But what helps is when you enter all these numbers, you can quickly reference, hey, what was that? What was base 2 doing? Who was it talking to before? What was it? You could pick these numbers out. Here in the red is where I'm explaining that when this pack switches to this base, it's going to talk to one of these 4 channels that are probably not used to talk most of the time. So again, pick your own way to organize, but as soon as you get to where you can see all the frequencies on one page, doing this part is a lot easier.
Let me ask a quick question. Is this program, this right here program you're showing, and the diagram we've been showing with all of the antennas, is that going to be in the handouts or included with the video file?
We should put them in there, yes.
Okay, we ought to do that so people can spend time looking at it, because it is fabulously versatile. But if you're like me, you got to sit down and look at it a lot closer before you really get it.
Well, the software is available on the website now for download.
All free, of course.
Yeah, plus this file that's already programmed with the shared and everything. So they can look at that file, which we're demonstrating right now.
So just to review, it's absolutely perfect if we can get this information out to more people. it explains that this RAD base can become a multiple channel wireless system. It was just purely on the scene change factor. With 10 scene changes, one pack could talk to 10 different bases, so 20 different channels right off the bat. As long as you organize, as the tech on this, you set it up just like you would an IP-based system. Instead of going in programming the frame with Bolero or programming whatever, you're setting all your programming here, and you program the packs to do what they're going to do, and you have it managed. Again, with the 3 different examples, I use the base-to-base one and the external aux in and out all the time. I do use a cross tune, but mainly to when I can't get. I want to save a few packs for someone who quickly needs to go to a channel that they want to keep on their same scene, if that makes sense. So, for example, a stage manager wants to hear show, but they still want to hear their stage manager without having to switch another scene. It's easier if you see it, but as far as programming, it's all here. This is the heart of the system right here. Is choosing how to route what each button's doing, and then choosing how to actually do the scene change. Right now, on the example I gave you, when you double tap the button, it's actually enables you to scroll through the scenes. You could do it to where you double tap and it goes directly to a scene. So here's a scene here, here's another, and here's another one here.
Hey, Rich.
Yes.
Chopper's asking, when you refer to scene change, are you triggering the scene change in the base station or in the belt pack?
So in the belt pack. So on this screen here, I'm in the belt pack tab, and I'm choosing on this pack here what button 1 does when I double tap it. So when I have it programmed to scene and I stab the pack, this is exactly this setup here. This is what I'm doing here. I'm double tapping. Let me go back. Let me go back further. Hold on.
And John DeMonico is saying, yes, please add
Right
Richard's diagrams to the handout.
Yeah, so see, I'm double tapping and scrolling between scenes. Now I'm testing the signal. I'm double tapping and scrolling. That's all based.
Can I explain a little bit how the scenes work?
Yes.
You're the boss.
So basically,
do I need to take the screen off?
No, you can say that. I'm sure you'll jump back in quickly. So you have a couple options. So you can set it up so a double tap on buttons 1 or 2 brings up the scene menu, and then you can use your volume controls to toggle through the various scenes you have set up. And you can also, or you could also program a double tap on any one of the 4 buttons to bring up a specific scene. So those are 2 options. Typically, I set it up so the person can scroll between the scenes and select one, and when they hit 1 and 2, it jumps to that scene. Also, Rich, could you go back to the base station page and just maybe quickly show people the different options on button 1, 2, 3, and 4 in terms of what they can make those buttons do? Thanks.
So most commonly, I just always keep button 1 channel 1, button 2 is channel 2 of PL. When you look at the bottom of the pack, 3 and 4 are on the bottom, WTA1, WTA2, or you can make it to where 1's an aux out. All these options are here. When you see +1 and +2, that adds the carrier back to when the base transmits back to you. You can hear your voice coming back through the mix.
Right, that gives you your side tone back through that channel.
Yes, and that's, some people like that, some people don't. Some people want to use an SA out to talk to a squawk box or whatever, somewhere down the chain where you don't need to hear your voice. You know that when you press that button, they're going to hear you, they're going to talk back to you anyway. It is preference. So
Rich, could you, after
yeah.
this too, could you show people how to access the audio roll off on the belt packs?
Sure. On the base tab, or yeah, on the base tab, all this is, again, is setting up the receiver frequencies, any other parameters you may want to adjust. Here's the routing, your power coming out of the transmit. The reason I have these at 50 is because both of these channels go into a TX8, and then I boost it from there. Enable, disable the transmit, all your intercom connections here. And all of this you can do on the pack or on the base too, and you can do the same on the pack when you go here. Here's where, when I go aux in, I could tell what channel to go to. So, for example, if I wanted to go to channel 2 and only go to on the wireless side, I would choose that. If I wanted it to go, like if, for example, you wanted to put program in, or you wanted to do that stage manager camera route that I showed you, if you want to keep it between wireless only, then local. If you want everyone else to hear it, then it's right there.
Rich,
Yes, sir.
we have a few questions here that you can address. So Jeff Jones just wants to ask, so we could download this free software from online, set it up, and just drop it in on site?
Yeah,
correct?
what I would, the question is how do you set it up right away? Or how do you set it up with your system?
The free software that we have on site, the one you're going over now, we can
Can I
set
answer
all
that?
this. Yep, go for it.
Okay, so this is our control software for the base stations and packs, and this is what we use to program. So what you would do is you would download the program, set it all up, save the file, and then when you show up on show site, you use the micro USB cord to program the base and all the packs, associated packs. When you save a file, it's good for one base station and its packs. So basically, if you have multiple base stations, you have multiple files, one for each base station, and you just program them however you want offline. And then when you get to your show site, you can just stab it. There's a quick programming mode that makes it very easy to program within, under a minute. You can program a system. So
now, Jeff, what about the rental company that's got 30 packs that they're getting ready to put into a box to load to a truck? How long would it take to fly through those 30 packs once you have the software completed the way you'd like?
I would say under 10 minutes.
So how long does it take? How long does it take to light up the pack, turn it on, let it go boot up, and then program it, go to the next one, turn it on? Is that all necessary?
Yeah, so basically, you obviously need a battery in the packs, but you don't even have to turn them on. The base station should be on. It takes under a second to program each one. So you can just open up the side port. Rich can show you, as if he has a pack, he can show you where that gets plugged in. Yeah. I'll pop up so it's bigger.
Okay, I'm going to roll through a few more questions as well. Go ahead, Rich.
Okay.
Go ahead.
I was going to say, here's the USB port. Can you see that? I can't see my camera now, but can you see it?
Yeah, we can see it, Rich.
Okay, so now, and I'm going to plug it in. I could immediately send information to the pack, and it'll program it instantly. So you don't even have to wait for this to power up. If there was a base, I would see signal and I would test it, and then I would move on to the next pack. So it takes literally 5-10 seconds.
And there's a special fast programming mode where it's you just plug in one pack after another, and it's done and easy.
That's a really important point. That final statement Rich made is that once you program a pack, and this goes for any RF device, give it a quick check. Plug in a headset and give it a check. If you hear yourself, then your programming went well. If you don't, you fat fingered it or did something wrong. And it happens about 2 or 3% of the time where you either don't have channel 2 correctly or you didn't program to one of your buttons correctly. So it's a good check. It takes all of 2 or 3 seconds to double, because the next time somebody's going to put that pack on is when you hand it off to a stage manager, 2 minutes before rehearsal. And so if there's an issue with it, you'd rather find it than have someone screaming at you that their pack doesn't work. A couple of quick ones here, Rich. You can answer that. Anybody wants to hop in also, please do. Derek Menigan's asking, what's the biggest advantage of wireless talk around when integrated with another system, with another wired system?
Well, yeah, you keep it separate. A good example is you do audio checks for pregame. You don't want everyone else to hear you, even though they may have the headsets off or their buttons muted for audio. You want to keep it separate. So the audio team is a perfect example of anyone on WTA.
Ike, you got something to add?
No, that was a perfect explanation.
Yep.
And stage managers as well. Our
Sure.
stage managers always are talking on their WTA.
Continuously.
Yeah, think of the traffic that you don't want on the show people to hear. It's just, it's those two are the big ones, yes.
Gary Sanborn is asking, how about the belt pack batteries? Lithium-ion, built-in charging capability, batteries, do they have to be removed to be charged? Could you address anything about batteries, anybody?
I'll do that. Yep. They do have to be removed to be charged. They come off quite easily. There's a clip right on the bottom. They just pop right off. They've got much more robust contacts than previous systems that were out there. They charge in about 2 or 3 hours. You can typically get, I've gotten like very long rehearsal days out of a fresh set of batteries in the morning. And I've been very happy with the amount of time, but I would say 8 hours is not out of the question. Yeah, that's kind of it for batteries. Was there more to that question than that?
No, but Alan Henning is asking, so, and this is a great question. It's a great way to make this distinction here. So a scene change is only for the individual pack user, or is it for everybody that's on that base? So yeah, you guys maybe try to clarify that, where that
it's the individual pack.
Yeah, so I chose these 2 packs to do scene, or actually this 1 pack to do it. But you can choose any one of these packs to have those same scenes. If you go into add scene, you have all the packs here. You could have one scene for all the packs.
You know, an example I use a lot for people when they're trying to understand the scene change thing is if you had like a Hollywood soundstage backlot kind of thing where there was, say, 6 sound stages on it, and you were the production manager for the whole site, and you had a RAD system on each sound stage. The production manager could have their pack programmed so that it had a scene with a listen and a transmit for every one of those sound stages. And you go out, you walk out across, or you jump in your golf cart or whatever, and you go to stage B, and you go tap on your scene change, and suddenly you're on the intercom system for stage B. You do your business at stage B, you jump in the golf cart again, you go to stage C, tap, your pack is now programmed to talk to the intercom system on stage C. And it could be the same for breakout rooms on a big corporate, or multiple stages on a festival or whatever. It's just that individual pack can be have scenes that will allow it to talk to every RAD system that's on the site.
Yeah, it's also
That's
a great
great
way to... Go ahead, Rich.
Well, I was going to say, some people choose to do that rather than do a DAS system, a distributed antenna system. So when people ask, how do I get a zone that's real far away? Well, you ask them, do you want to use the same packs, or do you want to drop those packs and use another set? I mean, if they're able to do that, use the same pack, then they could just do a scene change, go to the next rack that's full of RAD bases. And then they don't have to do all the fiber stuff.
That's right. Great. That's exactly what I was going to say.
I had something I wanted to address about Rich's distributed system that he showed there. I'm sure a lot of people that are used to using like IP-based systems are saying, well, you know, if you need to get to the dressing room or whatever, you can just run a piece of Cat5 down there and put up an access point, and you know, you've got the dressing room. You don't need all that RF plumbing. But on the other hand, for example, if you have a zone outside the stadium, yeah, you could run a piece of Cat5 down there and put up an access point. But when you do this, when you set up a receive antenna and a transmit antenna or whatever, if you're doing an event outside the stadium, like the draft or some event other than a game, for example, you can have everybody that's on Intercom go out there and the whole system will work just the way it's supposed to. Whereas if you put up an access point, you can get 5 packs or 10 packs, or depending on what the system is, but you can't get everybody to work on that remote zone. As soon as you put in the plumbing with RAD to do a remote zone, you can use every single pack that you own and 30 rental packs or whatever in that zone. It picks up, there's no limitation on how many you can use.
Plus, you can get mics and ears on it too, on the same backbone.
That's a good point. Yeah.
And I always tell people, use tools. If you have access to both, I would always say use the RF option and use the based option, because you want to do what people ask for. You want to provide the service. So if you master both, your show is going to be a lot more stable. I mean, to me, analog RF is a lot more stable based on what I've seen and experienced. But there is a trick to set it up. As long as you learn this, if you go through this a couple of times, you got it. You could see the routing right here, and you could learn how to use this stuff as long as you take the first step.
With that said, maybe we could segue into some practical experience. Ike, you and I were talking earlier about some of the places where RAD shines in terms of its simplicity of setup. I know we talked about a lot of the features that we've developed to kind of make it emulate some of the digital systems in terms of routing, but on its base layer, it's a very simple system, and it has.
Yeah, absolutely. I would like to address that immediately, but we did have a question about the headset. Here it is. It's we've gotten some very favorable comments about it because it's extremely lightweight, very comfortable, but it does have the enclosed ear pad, and I used it on the Grey Cup, the Canadian Football Championships, and the comments from everybody was like, wow, this is like really light, really comfortable, and I can hear what what I need to listen to. And list is about just under $300, as James said. It's like $299. So there's the headset. One of the first things, like a lot of questions, like why use RAD? Well, for one thing, really rapid deployment. If you have a system on a broadcast truck, for example, 15 minutes after you park and power, you can have your A2s and your V2s and your utilities and whatever can be walking around the truck compound, walking around the stadium, talking to each other. It does not take a long time to deploy. Basically, put the antennas up, turn it on. If it's programmed, you're ready to go. I've been on lots of events where the intercom is turned on day 2 or day 3 because it's just days of running cable everywhere. So you can very quickly deploy RAD. Another thing, everybody tends to think of the high power 250 milliwatt applications and all that. But again, if you have breakout rooms, for example, you can put the base on 20 milliwatts, stick it in a corner, put the packs on 10 milliwatts, and have a separate intercom, 6-up intercom system in each breakout room if that's something that you need. Again, very quick and simple to deploy. If you have an event like an opening ceremony at the Olympics or something like that, and you've got 200 talent wranglers, then you can, cross-rent as many packs as you want, because every single pack is compatible with every single base station. That's every one we've ever made. I think James mentioned that earlier. You don't even absolutely have to make sure that the firmware is completely the same. I don't think it's always a good idea, but it's not like it won't work kind of thing. And so you could have 200 people listening with 6 of them able to talk, or 12, or depending on how many base stations you have. So there's no limitation that you run into, again, with the IP-based systems, about you can only have 60, a total of 60 packs on this, in this RF space or whatever. So it's got some flexibility for other things that you may need to do. Again, like with the example of a bunch of talent wranglers with, you know, hundreds of athletes coming on the field or something like that. There's a certain amount of field serviceability to it. The belt clip is that quick to replace, and it costs $5 or $10 for a replacement belt pack. I know that some systems, are not a replacement belt pack, a replacement belt clip. I know that some systems, I remember my dealer cost on that wire clip on the BTR pack was something like $34 for a piece of wire, and it didn't come with the 2 screws. The XLR connectors, which has been a point of breakage on other systems, are field replaceable. You just take a screwdriver, take out 2 screws, and a good way to get them out is to stick a headset jack back in there, pull that out, and out comes the modular XLR connector. This is also good for if you have mixed inventory of headsets, where you have, for example, some 2-channel headsets that use a 5-wire XLR connector. You can just pop that 5-wire connector into the pack, and you're in business. So there's a lot of flexibility that way. They're also, with the new firmware, they're pre-configured to be post-repack compatible, which means that you can, if you have a Part 74 license or are able to access those frequencies anyway, you can use the frequencies in the duplex gap. You can use the frequencies in the guard band. The systems are already pre-limited to 20 milliwatt output on the base station. So if you go to those frequencies, you select a frequency over 608, basically it will, the base knows that it's only legally allowed to transmit at 20 milliwatts, and you can go to town. On an event last fall, I can't remember if it was the Red River Rivalry or the opening at Notre Dame, but one of them I had doled out a frequency that was in that range for one of the RAD systems on the field, and I bumped into the A2 that was setting it up, and he goes, you know, I can only get 20 milliwatts out of this. And I said, oh yeah, right, I put that up there. I said, have you walked it? He goes, yeah. I go, how's it working? He goes, it's great. I said, well, then let's just leave it there. And we did, and he did the game, and there was no problem. So that's another thing that I had to mention. Those are mostly my key points. I would agree with Jeff that I have not had a huge amount of issues with using more packs than receivers. On the Taylor Swift Reputation Tour, we had 24 receive channels and 40 belt packs. And we did, I forget, 70 shows around the world, and it worked everywhere we went. So it's pretty flexible that way. Any questions?
Yeah, there's a few questions. It's sort of straggled in on the end there. Are there any changes or options to apply outgoing call signals on any of the buttons?
Outgoing call signals?
Call light signals.
I don't think so. Rich?
But lights on the pack, or to trigger a light?
either call lights on the packs or call lights to an external two-wire system? The question is from John Christie.
Okay.
Oh, like
No,
the
we don't
relay.
pass the call light signaling, or we don't generate call light signaling of
Okay.
either of the two. However, if you just need a plain call light, you can always use the relay connected with SA.
Right. Also, how do you default a system as a rental company to empty when it comes back on a rental?
You would you would write and save a program in our software. You would basically just you could either do it for I'm in Toronto. You could do a coordination that will work in Toronto and have that as your default. But again, everything programs almost as soon as the USB connector goes into the connection.
I
That's
think
about
they're
how.
asking as a rental house, they don't want to send it out with a lot of random stuff already programmed in there. They'd like to send it
Well,
out.
that's what I'm saying. So you would go into our software and write. I mean, basically,
Right, your default program and put it in. Okay.
as you opened it, it's practically a default program anyway. It only gets
Okay.
complicated when you make it complicated.
Do you need to undock from your PC when disconnecting the USB connector? This is from Eric Clark.
No.
It's not like a USB key or anything like that, right?
No. Nope.
The videos, Richard, you had, we'll put those on with the in the files.
Okay. Yes, they're on the website as well.
Okay, good. Edward Gonzalez could not find them on the website. So at the very least, we'll get the links for him.
Okay.
Jeff Jones does say a big advantage is RAD units can be RF coordinated, unlike 900 megahertz and DEC systems. So you can fit them into your whole plan. And Gordon Nemo Smith says, one last question. Would you recommend leaving batteries in the chargers when you're not in use for extended period of times, like when your theater's closed until the COVID-19 is done? Or you leave them out of the chargers?
I'd probably just turn the charger off. The charger has a power switch. You should probably charge them, once every 3 months if they're mothballed, but more than that is not necessary.
In other words, they do sort of run down if they haven't been used for a while.
Yeah,
But
I think
you'd rather not have them sitting in the charger.
It would be okay if they did. I don't think there's anything bad about it, just from a fire hazard safety. I just want them powered off if I wasn't there personally. But the batteries.
Well, there is a very specific protocol for storing lithium-ion batteries.
Yeah.
In fact, there's a good thread about that running on ProSound Web right now. The batteries should be at about 90% charge, and then best practice is take a small bag of desiccant, throw it into a plastic baggie, purge the air out of the baggie, and put it into a wine cooler or refrigerator that you don't go into a lot.
Along with your best, finest wines.
Of course.
And the last question was one that we didn't hit at all from a long time ago. Where is it here? What are the incoming features to be used with the Ethernet ports? Will we be able to program by network eventually?
Yes.
That was from Derek Menigan.
Yeah, once we activate that, basically you'll be able to see it on the network.
Okay, cool. So I think we got a ton of questions. I don't think there are any more after that. Actually, there are a few.
And Ike's got one thing.
Yeah, I got a couple of quick things, Pete.
Yeah, go ahead.
One, just wanted to mention that the modular XLR connection is universal across the system, so it applies to the base stations as well. So, for example, if you're reconfiguring a rental system to go out with 5-pin 2-channel headsets, that you can also just quickly change the one on the base station as well, so you don't get into that situation where you can't check a headset on the base because it's got a different connector than the other systems. And the other thing I wanted to mention is that if anybody's out there that are legacy users, particularly people that were early adopters, please reach out to us to just make sure that your systems are absolutely up to date. There were some hardware changes to some of the base stations to the early base stations. And, we really want your systems to be working optimally. And if you're, ever have questions about any of that, then reach out to us or to Stephen Copeman, our service manager. And, we're here. So we really want to make sure the stuff works optimally. Any questions, just call us.
Jason Glass asked, and I don't know what this means. Hopefully I'm not being nasty here. Do the Gargers run a maintenance program?
I think maybe you meant chargers.
Ah, okay. That's a good pickup there, Kelly. Yeah, do the chargers fix your old batteries? Can you restore a battery with the chargers?
I don't think they do run a maintenance program, but I guess we've had batteries out there for over 3 years and we've had pretty good success with them. One quick thing about the batteries is if you don't want to let it discharge, past 6 months, if the battery discharges past a certain point, then there's circuitry inside the battery that won't let it charge again because it thinks there's a fault and it's a safety issue.
Right.
So
right.
So every 3 to 6 months you should run it on the charger at least once.
Well, also lithium ions don't require the same kind of maintenance that NiCads and nickel metals that we're used to. And basically they have a certain amount of charging, number of charging cycles, and then they're pretty much gone.
Okay, I think just to keep everybody refreshed, we should go back to the top of the show and run it again.
Absolutely, absolutely. This is a company, I think everybody would agree that it's grown out of engineers, of users, of people that have had their hands on this hardware from day one. But before this hardware came out, they were using this, they were understanding it. And I think that brings a really unique perspective, Pete and Mac, to how things are done and how they've implemented those. So please, here's all their contacts. Reach out. They will get a list of all the questions that were submitted today, even the ones we couldn't get to. I saw a few notes that just kept coming in, right? Different things for dual channel assigns and Dante and all those things. So they will get a copy of all those. Reach out to them. This is the world we're in right now, folks. We have no place to be, literally. So there's no excuse to not communicate. Grab these emails, take a screenshot. I would say universally, we love questions. That's the power of this platform. Regardless of the manufacturer that's on, obviously we had a ton of questions today. We've had a ton of questions in every single session, which we love because that's what it is about. So, when we merge from this and you get the all clear from your governors in your areas and you connect up with your shops, get your hands on these boxes. All right, get in there, and that goes for every product. Just get back in front of it. For now, though, this is gonna work really well.
Yeah.
I will tell you, April 6th, PWS will be on. This is going to be, we'll be updating our website a little later this week with the following week's sessions, but April 6th, PWS, questions about combining RF over fiber. So all this stuff that you saw discussed here, we're going to keep diving in deep there because we know there's a lot of interest in that RF. James teased this as well. April 10th, it's not even up on the website yet. We're calling it the RF Faraday Cage Match. All right, so this is Pete and James and Henry, Jason, Andrew, Ryan, Steve, Kevin. We are basically, me and Mac are going to be the referees, and we are going to come up with just some of the most, outrageous implementations they've ever done. Stuff that by physics shouldn't work, but it just did. So we're going to ask some crazy questions.
Mr. Caldwell from Australia to join us too. So we'll get the upside down frequencies, right?
Oh, thank God. Yeah, because we're going to have both right and left turn, right? So we're going to be good. But tomorrow, Pete, real quick, we have Lunch with Pete, tour RF coordination process. Just give us a quick rundown on what you plan on covering there.
When I was with Tim McGraw and Faith Hill, after about 70 shows, and we had another 70 to go, it became obvious the whole process was exactly the same every single day. I mean, the movie, what's the movie called?
Groundhog Day.
Groundhog Day was written about an audio guy. That was all about an audio guy. Gets out of the bus, comes in, picks his frequencies, puts them in the equipment, pushes the equipment under the stage, goes to sleep for 3 hours, puts the equipment back on the truck, goes back to sleep. I mean, that's basically what it is. And I wrote a book about it, a little short book, 20, 30 pages, which outlined exactly the process I did. And I'm going to go through that with my TTI, with my Field Fox, and all the stuff, and show you the whole process. So that'll be fun. And you can download the book on the website already if you want to read and know all the answers up front.
There will be a test. And James, thank you so much for joining us. I know, man, we kind of just, these weeks are coming together. We're, as fast as the days come, we just keep throwing things. You guys really stepped up, and thanks for this deep dive. Really, really do appreciate it, man.
Yeah,
I will.
Thank you. And just a quick thank you to all of the people that signed on and wanted to learn more about radioactive designs. We appreciate it.
I will now ask the first question that came through in our list here. Person wanted to know, and I have to go look at his name here. He wanted to know, how has COVID-19 affected audio people? And look at this. This is what it is. This is what Kelly came up with when we both realized we were going stir crazy at home, binge watching the same series over and over again. We had to have something else to occupy our time. So why not? Why not do these shows with every different company in the world? Exactly.
Yeah, so, Faraday cage match, it's going to be a lot of fun. Thank you guys for being a part of this. We really do appreciate it. And we're going to be looking forward to all the new innovations that emerge out of COVID-19. Can you imagine all the ideas that are going to come in over the next 12 weeks? It's going to be amazing. So everybody have a great night, and we'll look forward to you on the next one. So long.
Thanks, guys.